limit is y goes to pi over 2 of 1 minus the cosecant of y over the cotangent of y. The first thing we're going to do is try plugging a pi over 2 in for each of the y's. So that'll give us 1 minus the cosecant of pi over 2 divided by the cotangent of pi over 2. So 1 minus the cosecant of pi over 2 is 1 over the sine of pi over 2, which is 1 over 1, or 1. And then the cotangent of pi over 2 is the cosine of pi over 2, which is a 0 over the sine of pi over 2, which is a 1. 0 over 1 is a 0. 1 minus 1 is 0 over 0, indeterminate form. We have to rework this. We don't have matching trig functions, cosecant and cotangent. Neither of them are squared, so we don't have a Pythagorean trig identity. At least not yet, but one of them is a trig combination in the numerator, so we can try multiplying by a trig conjugate, which can lead us to having a Pythagorean trig identity. So I'm going to rewrite the exact expression, and I'm going to multiply by the conjugate of the trig combination, which is the same two terms in the trig combination but opposite sign between them. So that'll be 1 plus cosecant of y. And I'll put it in the numerator and denominator so that we are multiplying by a form of 1. We're not going to change the value, just the look. In the numerator, we have a trig conjugate pair. We're going to FOIL that out. First, 1 times 1 is 1. Outside, 1 times a positive cosecant of y is a positive cosecant of y. Inside, negative cosecant of y times a 1 is negative cosecant of y. And last, negative cosecant of y times a positive cosecant of y is a negative cosecant squared of y. Now the outside and inside terms after FOILing out a trig conjugate will be equal value opposite sign and will cancel. The denominator is not conjugate pairs. I'm therefore not going to FOIL or distribute in any way. I'm going to keep it factored. Let's rewrite what we have. We should still have 0 over 0. We haven't changed that just yet. And we do. It's important to see where the 0 over 0 is happening here, because the 0 in the denominator is happening due to the cotangent. Cotangent of pi over 2 is cosine of pi over 2, which is 0 over the sine of pi over 2, which is 1. And 0 over 1 is a 0. It's happening because of the cotangent, not because of the 1 plus cosecant of y. And therefore, we're not going to factor that numerator, even though it factors as a difference of squares. You could factor and cancel, but that will take you back to your original fraction that we had. That's not what you do with a trig conjugate. What you do is make use of a Pythagorean trig identity to convert what you see in the numerator here. Now, the Pythagorean trig identity involving cosecant is cotangent squared of y plus 1 equals the cosecant squared of y. Now what we have is 1 minus the cosecant squared of y, so I'm going to subtract the cosecant squared of y to the left side and subtract the cotangent squared of y to the right side, just to rearrange it. So we can see that 1 minus cosecant squared of y is the negative of cotangent squared of y, and that's what we're going to replace it with in the numerator. So we will have limit as y goes to pi over 2 of negative cotangent squared of y divided by cotangent of y times 1 plus cosecant of y. And the cotangent of y is going to be 0 as y goes to pi over 2. And we need to cancel. There's 2 of them in the numerator. We can only cancel one of them out with the 1 that's in the denominator. But that should eliminate the 0 over 0 indeterminate form. We're left with a negative cotangent of y over 1 plus the cosecant of y. At this point, we can plug in a pi over 2 for each of the remaining y's. And that will give us a negative cotangent of pi over 2 divided by 1 plus the cosecant of pi over 2. The cotangent of pi over 2 is the cosine of pi over 2, which is a 0, divided by the sine of pi over 2, which is a 1. 0 over 1 is a 0. So we have a negative 0 divided by 1 plus The cosecant of pi over 2 is 1 over the sine of pi over 2, which is 1 over 1, which is 1. Negative of 0 is 0. 1 plus 1 is 2. 0 divided by any non-zero number is 0.